All right, we are live. Let's see here. There's no intro this time. We're not doing an intro. Whoever's here is here. No one's here right now, so let's, for the video, I will explain. Today we're going to be making the the server side of our WebSocket stuff. So in the previous stream, we did some client stuff, basically setting up so that the client kind of understands different messages and so on. And now we're going to be doing the server side of this. So what I'm doing right now, for just before the stream and now, is setting up basically a simple multi-threaded web server, sort of. We already have some of the stuff from before, but we're basically setting up the actual multi-threading and so on to work with this. Let's see here, by the way, we should pull start for sure. Let's see here, we're gonna invent some thread state. Here I might make this a little bit larger. Let's see here, we don't want necessarily a receive buffer, certainly not one this small necessarily. If we're doing WebSockets, it actually wouldn't be that much of a problem to have it be this small. Probably we're going to make it a little bit larger though, so that we can receive basically whatever, right? Whatever kind of request. This is something you can of course like tune over time, right? All right. We do want to receive buffer. I'm going to say that, yeah, let's call it the receive buffer. Actually, it's fairly descriptive. We want this to be a slice of bytes. We're going to pre-allocate a, fair amount there. Bytes received now, not really. We do want, let's see here. I think these are the things that actually come to mind right now. The receive buffer, of course, you can establish this in a thread. So maybe that's not necessarily something we need right now. Certainly we want the socket. Let's see, we're gonna pass this down and we'll see kind of what happens, right? Because here we're gonna have handle client, handle request, let's say. No, handle client, because we can have multiple requests actually, in fact. And we're gonna say client state is thread state, right? But here, what we're actually going to do is we are going to say make, or new rather, sorry, new thread state, like this. And we do need a client allocator here. Let's see, we have to, for some reason my accept TCP fails on Linux but works on my Mac. Same code, running the latest dev branch of Odin. Okay. When you do this, have you debugged it, as in, gone into it and seen sort of what's up? Because probably the actual debugging would most likely tell the story. Are you getting any kind of error message, by the way? Actually, we need to client arena new, let's say virtual arena here. We're gonna pull in mem virtual, and then we're gonna say virtual arena init, and here init, right, growing, let's say. That should be fine. Client arena here is already a pointer, so we can basically leave it like this. the amount of space we want to reserve, we might say 4 times mem kilobytes, like this. And here we want to pull in mem also, like this. Mem kilobytes here should be a constant. Let's see, dot kilobyte, not bytes. I could take a look at this. Certainly we could pull the latest Odin and see if we also run into it, this problem with accept TCP. It could simply be a difference in assumptions between the two platforms. You will run into a lot of these types of issues where, for example, Linux may require you to do something before you do a certain other thing, and so on and so forth, right? There are lots of these hidden assumptions between platforms and so on. Even in the presence of, you know, POSIX, for example, right? Which is supposed to be this unification of all of these, you know, interfaces and so on. Even in the presence of that, you will sometimes find that stuff is kind of broken and bad, which is unfortunate. Let's see here, pull add task. We want task proc as the, right, here we actually want our client arena. This takes a mem allocator. So we actually need to create client allocator like this, arena allocator. This takes this client arena like this and creates an allocator from it, right? Let's see here, pull out task, data is going to be our client state. This is already a pointer, so we really should be able to just pass client state like this. Fail to accept connection, bad enum value 14. So the 14 here is actually, so hang on, TCP accept TCP, network error. So hang on, bad enum value 14. Hang on. Can you show me the actual code that you're executing? Because the enum value here should not be this necessarily. Like, I'm not sure that this makes a lot of sense because we don't actually have an enum here. The error that you get back from accept is actually is an actual union. So we shouldn't get enum value at all here, right? And if you output this, so if you output this with %v, you should actually get a union value, right? Something readable. Enum value is usually what you get when you have erno. So for example, if I go up here and I say, we have OS already, right? Let me show what I mean, right? OS open, for example, right? Returns erno, right? So if we go to OS open, we go to erno, we'll actually very quickly realize that this is an I32, right? So there's some level of, you know, oh, that doesn't make a whole lot of sense. Bad enum value seems like something was cast to an enum, but it's not actually a valid member at all of that thing. The number 14 does not make sense there, right? So one important thing, if we look at accept actually, have you checked your return values? So you have first a socket, and you'll note here that this is just an I64, right? It's just a number. Then you have your endpoint here, right? Which is an actual structure that represents the endpoint. And then you have an accept error, which is a network error, which is just a normal union value. So yeah, I'm curious if maybe, yeah, what the, I would have to see the code probably to debug this, I'm assuming. If you have it online, we could take a look at it, probably. Let's see here, we have our client allocator. We actually heap allocate this here. We could also add all of our thread states to a list, actually. Basically a dynamic array is what we could use for this if we wanted to. So we can basically clean them up. We're not necessarily going to get into that now because it doesn't really, matter that much at the moment. So handle client is actually going to be effectively a bunch of this code, which we also are going to clean up, of course. So let's see here. We have these bytes received. It's basically at this point the cutoff is, right? Let's say handle client down here is a proc. It actually needs to take a task, which is thread.task. You may have seen this before in some of the other stuff we did. And here we actually need this we need to interpret this stuff here. So we're gonna cast t.data. This is a raw pointer, right? Which we're gonna cast into a pointer to thread state. And then we're going to basically have our state here and so on. And of course, this is not going to compile now. There's lots of stuff here that simply is not written this way, right? We could say client socket here. It's actually state.socket, for example, right? And now suddenly we have that bound. Let's see here. Thread state. This is not available here. We're going to pull that up there. Welcome message doesn't make any sense anymore. That's fine. Receive buffer is not really needed, so we're going to remove that. Client socket declared but not used. Here we can actually just say, okay, we have this client state here, right? We're going to say client state socket equals client socket like this. Remember, this is just a number, so we can copy this however we want, really. Pool add task needs, of course, the client allocator, like this. Not the arena, right? Because we create the allocator from the arena, right? Receive buffer we don't have here. We could say receive buffer like this is equal to state buffer. Receive buffer like this. Potentially, we could also say receive buffer, and then we could effectively have something here, right? That kind of depends what we want to do, really. We can also say, by the way, context.allocator equals t.allocator. And this is because every task actually has the allocator for that thread. So this is a useful first line, basically, to have, right? We could also say context.logger is log create console logger. Now each thread will actually have access to logging, so we can actually, do this properly as well. Let's have let's have this buffer just for the time being. I'm not entirely sure that we will keep that as it is right now. Here we have a break, which we don't really need here. This 4 bytes received here. We do want a 4 effectively that we can break out of. So I think actually we are going to stuff most of this inside of a 4 here. And the welcome message, like I said, we're not gonna keep this really. Well, I could have, of course, just used that. Actually, I'm going to maybe I should keep this. I'm not sure. let's just do this here. So we have something that we'll be sending. Now, helpfully, we are also done with compilation errors. That doesn't mean that this works, of course, necessarily. We have a basic structure. We have a handle client function here for each thread to run and so on. Here we have this pool add task, which should basically set up the client state and so on. And we have a structure for client state, basically this thread state here. So we can basically stuff whatever we need to in there as well. Let's see. Buffer init allocator, by the way. Right, this will use the context allocator from up here, of course. We could try running this and see, you know, what actually happens. Let me just verify some assumptions here. This is just, it takes the port to listen to task HTTP server 4200, for example. And we of course need our double dashes here. Fail to listen, address in use. That is indeed because we are still running this one, presumably this Go version, which we're gonna yeet. I'm gonna close that entirely and just sort of let this one run. So this is now running on this port. Let's see here if I can quickly just verify that. So we're clearly basically setting up this handle client to run, right? We're logging here that we're getting a request. It's a get to slash. The protocol is this, which the space here we need to remove. And we have no headers, which I sincerely doubt, of course. That is not the case. So we have some parsing bug here in our parse request code. And that is actually in the HTTP module, parse request, I think. Here we go. Let's see here. We could see actually that the protocol obviously is lacking, or it has an extra space, and that is probably because we're not skipping something. It tends to be the case. So we can see here that first we create our tokenizer, right? And then we expect an upper symbol. This is of course the method, right? So in our case, we only really support get at the moment, and we do this in the actual parsing, which is of course not what we want. We're gonna modify that. Then we can see here that we skip spaces after this, right? And then we read a string until we reach a space, but we're not skipping spaces after that. So we're gonna put just after the path, we're gonna skip spaces, right? After this new line here, this is a CRLF, right? Windows style. We are actually going to skip. Here we could be more specific and actually say skip string like this, right? We could skip that specific string instead, right? Which matches our read until. And then if we parse headers, we should then be able to see, oh, okay, now this makes sense, basically. Here we probably want to read an M body as well, but we don't really have M body. So we basically don't support any kind of body at the moment. So that's something we should add as well. Here we can rerun this and see if we see a different value here. We do not, in fact, see any difference. Let's see here if I can... one of the things that I have learned over time is that I'm not the best at writing my task files so that everything recompiles like it should. So we're going to see that that makes sense. And we can see here that the HTTP server is actually depending on HTTP client, and that's not really the case. It should depend on the HTTP package plus the server. in fact. So we're gonna change that a little bit and see if we now see a difference. And here we can see that we're seeing a difference, but we're actually seeing here that, hey, I failed to parse this message because we can't find an end to one of the headers. So that's clearly here. This dash, presumably, expected name end. It might be this one, which would be not what I would expect, maybe actually. Let's see what is happening in the code for this server. No, this is of course the HTTP package again, or parse request colon in the parsing file. Let's see here. We're clearly in parse headers. Parse headers is general code that deals with both responses and requests. So this is very general, and presumably here we actually have this tokenizer read string until, right? The only reason we would end up here is if we can't find a colon, right? Because you can see here, tokenizer read string until, right? We are looking for a colon, this one here. We are finding an end marker, presumably, because we are returning expected header name end with this stuff here. So clearly something is going on there, right? How do we figure this out, right? We are though it could be this one. We could just log here, surely, header name, to see which one we're actually attempting to read, at least. Okay, so we're saying accept and then accept language. Oh, hello. Welcome to the stream. Yeah, that is the most popular video, for sure. I would hate for that to be the only video, to be clear, because it might seem like I'm just sitting, you know, I just have a bunch of opinion on some languages and that's it. Hopefully I do not come across as, you know, that basically. But yeah, it was a good, you know, nice video to make, to be honest. It is just all my honest opinions, obviously. It does seem to also have struck a chord with some people, I would say. A lot of people are not necessarily super happy with Rust, is what I would say. I would characterize this as that. Expected header value end. Oh, hang on. Have I? No, header name end. So we're failing at parsing a header name. So it's definitely up here. An end marker error is what we are getting here. The tokenizer yeah, the tokenizer can only really return one error for this. It's this expected end marker. And this is basically, we are not finding the thing. We're not finding a colon in our, right. Let's actually log our header values as well, because I'm a little bit curious here. Okay, so we're reading, of course, accept language entirely. We're reading this entire thing. So it is accept encoding that we are failing at, clearly. Now, this is interesting, right? Because there's no reason accept encodings should be bad here, right? In our code, we are definitely trying to read until colon, and we can see that there's a colon, in fact, in this, right? So that's interesting. Why would we end up in that situation, right? So here we are starting this leads me to believe that the source is really restricted here, right? Because we are putting as data the rest of the string, and that is just accept. So clearly here we're receiving too little, in fact. Entirely way too little. Now, this might have a few reasons. It's probably not that we aren't receiving enough. It was simply the case that we were passing not enough of that to our parse request function, right? So we were passing bytes received here, right? And so on. And that was the issue. Now we have an actual honest to God unexpected character in our headers, right? And that's quite a different story. If we go to parsing here and we go to unexpected, let's see here in the tokenizer, sorry, unexpected character, we have ended up in this spot here. The reason for this is because there's nothing here that handles a question mark, in fact, which is of course an oversight, and so we're going to add that, right? I'm gonna see here if I can find. We obviously have not found any other punctuation of that kind either, so we probably want to add a few of these in one go, presumably. So here, what I'm going to do actually, I'm going to set a mark here. Reasonable minds can disagree. I like Rust for what I'm doing, but I understand that your use cases are different than mine, and there will never be a language for everything, everyone. I think your video made it clear about Rust sellers. They're gonna no. Just to be clear, I'm not saying that Rust people were really the most vocal at all. In fact, I would say this, that the vast majority of all of the comments have always been very positive on their channel so far. I'm not big enough to have negative comments, generally speaking. I've had 2 comments that I would characterize as essentially negative. And none of the responses that pointed to Rust being good or whatever, like people disagreeing about my position on Rust, none of them have been negative, just to be clear. That I would say that it's the opposite. People are very happy to hear that other people have similar opinions on Rust, probably because they feel like no one thinks this, right? Overwhelmingly, obviously the hype is basically that Rust is, of course, if you're not using Rust, you're doing something wrong, and so on and so forth, right? And I think people were very happy to kind of hear that that's not necessarily something you have to take to heart, right? There are actually, in fact, people who think differently, and so on. So I think that was maybe what I meant, because like I said, there have been no negative opinions from any Rust people. just to be clear, right? So let's see here. Here we want question mark. We want also exclamation mark, let's say. Is that what really exclamation point is what I want to say, to be honest. Let's see here. Question mark, exclamation point. And here we want case question, or no, like this, of course. Like this and this. Return a question mark, and of course this. Beautiful. Now we should not have this parsing error anymore. But yeah, just so I don't want to give the wrong impression that I have been attacked by any Rust zealots, to be honest. That's not. In fact, I haven't been attacked by anyone. I think it's mostly that people are very happy to hear that there are people with the same kinds of opinions as them, to be honest. And that's kind of more what I have seen. The tokenizer is not in the task file. We are not compiling again when we... There you go. Hang on, this is... tokenization. Now we're parsing this request as we should. I also get the impression that a lot of the people vocal about the language don't have significant experience with it. This is 100%. This is an impression that I get a lot of the time, yes. And this applies, of course, like this is the case everywhere. The strongest opponents of Haskell are the ones who have literally never used it in production. The strongest proponents of Haskell are the ones who literally never used it in production. Basically, everyone who actually has used Haskell in industrial use cases and so on are fairly middle of the ground, I would say. Certainly, I find myself in the somewhere in the middle. I think it's overrated. It's 100 times better than something like OCaml, which again, the only people who like OCaml are effectively people who have never actually made a backend service in it, or they have blinders on basically. The runtime is so sparse and shitty that there's no, you get nothing out of it. If you compare it to Haskell, which is far beyond what you have in OCaml, it's like this is not even a contest, right? Threading is so much better. And so on in Haskell, that it's unreasonable to think that OCaml can ever compete, and so on. But yeah, overwhelmingly, the people who are the loudest about languages and so on are usually the ones who have the least experience with them, I would say. There's one notable exception to this, I would say. No, actually, okay, so I'm going to qualify this and bear in mind, bear with me here. In closed communication, the ones who are the most positive about Erlang are the ones who have actually used it, to be honest. But they don't exactly go out and tell the world over and over and all the time, to be honest. Elixir is definitely one of those things where a lot of the very vocal people haven't put anything together with Elixir. But yeah, this one is a little bit like Erlang and Elixir are so unique in terms of runtime and so on, what you get out of it, that I can see, because I definitely recommend it to people. And I've written tons and tons of code in both of these, and I have built my career on it, on Erlang and Elixir. and have run production systems in it and so on. And I do recommend it. It is far and away the absolute best environment to have for backend work if you look at it from a general perspective. For specialist stuff, there's always something that can beat it. So if you need something to be ridiculously low latency, for example, Erlang is not going to be your thing, right? But if you want lower average latency across hundreds, it can be 100,000 clients, Erlang is going to probably beat your thing. The average latency is going to be lower probably for most use cases and so on. So I do think in general, though, the people who are the loudest and like to talk the most are definitely the people who haven't actually done anything in the thing that they're talking about, right? It tends to be the case. Anyway, we're parsing this request now, so that's nice. This also means that we can go in here and say, hey, debug F, we can probably be without, right? We're gonna do that. So now we're parsing these requests. Now the question here is what we want to do with it, right? We obviously want to set up the negotiation for the WebSocket stuff, right? We are going to take over this connection. So what we could set up is basically a very simple kind of, hey, if it's on this path, expect some WebSocket negotiation, and then basically move into a loop that just deals with WebSockets. Basically, that's probably a good bet here. What are you using Rust for, by the way? You can answer while I'm gone. I'm just gonna get some extra coffee. All right, let's see here. Now we want to, we're never actually sending these welcome bytes, correct? Probably. Let's see here. Game modding as a hobby, and I decided to try it out for one of the proprietary file format extractor creator tools I made. Okay. I'll be honest, this is exactly the kind of thing that I would expect Rust to not be that great for, to be honest, and so on. It would be probably very straightforward to do in a lot of other stuff. I guess it depends on what you're doing exactly though, right? Game modding, are we talking you're injecting DLLs? Are we modifying binary files? Not being certain things? Because game modding, yeah, I guess what I'm thinking is game hacking actually, to be honest. I realize now it's probably, so game modding is that like, oh, this specific game has this file format, I need to produce a file that has those things, and we have assets, maybe a packer or something. Okay, so it is a little bit of game hacking. I've only done a little bit of this. I made a trainer for Company of Heroes to basically knock out, depending on what you clicked, of course, right, in the trainer, it knocked out basically unit costs and stuff like this, right? So you could basically make units cost nothing and so on and all of these things. But I haven't done almost any of those things. I also built a little bit of stuff in Zig for injecting code into Windows processes and so on. It's up on my GitHub actually. That was a while ago though, to be clear. But yeah, I did a little bit of this. It's an interesting area of stuff to be, you know, I do like that whole thing, especially there's something very alluring also about just going into process memory and just sort of changing stuff. I just love this idea of effectively being able to say like, no, we're just gonna modify that, you know, in the actual binary of this thing and so on. I really like this. And also reading memory. I mean, being able to read state of processes and stuff like this. It is a very nice, I don't know, there's something nice about it. I don't know, I can't even explain it, to be honest. Here we actually want to call this request. This is still not responding as it should. Let's see if we can sort that out before we go forward, because it could be there could be some problem here that we have not foreseen, right? So we have this buffer here, right? We create this buffer just to hold some space. We write some stuff to it. Obviously this is just a bunch of, you know, very manual stuff. We write this HTML. We produce the slice of bytes from this, right? And then we know that we receive our request here, right? We can see this in our logs. And then we're supposed to be responding to this. But it certainly seems to not necessarily be the case. If the request path is favicon ICO, we actually just say, no, that's not a thing we do here. Otherwise, we are going to send this welcome message here. Let's add some logging here, presumably, to see if that actually is a thing that happens, right? So we can kind of just do this. And here I actually kind of want to say, write out what we actually wrote, to be honest, right? And what we can do here is actually say bytes sent to bytes sent plus n, which should give us each range. So if this takes multiple sends, we should basically be able to see that it is actually sending this range of values and then this range of values and so on. Sent 94 bytes, 200 okay, content type. Then we end our headers here. You can see this double new line, right? And then we send the body here. And I can tell you that the request is not finishing. If I go to my browser here, you'll see that this is not actually finishing here at all. If I refresh this, we can see here that, oh, this is not actually, there's no action here whatsoever. Though now I'm getting an error in the console. Embedded slice indices is out of range. That one is unexpected. But yeah, here we can see nothing is happening, right? We're in fact sending this stuff, right? But we're not seeing any of this being displayed or otherwise. So let's see what that is about. We can see that we only end up here once, right? This is definitely only happening once. So this for loop must be finishing effectively, right? If I said net close client socket here, we could break here maybe. That is not going to survive, of course. We're not going to do that in the long run. What happens here? When we close now, we can see here that, oh, this now renders, everything's fine. We can also see that it 404s on this fav icon here, or should rather. If I refresh this, if we request twice, we in fact, we get the slice indices -4 to 0 out of range. Let's see what that's about actually. I think that's 144. Right, here when we control F5, it seems like basically we are ending up in a case here where data is in fact nothing. So that's probably the case. And of course, if we have no data, then obviously the data has no new lines. It would be a fairly sensible assumption. If I control F5 now, what happens here? We still get what I assume is a seg fault. Let's see. We could GDB this. I should make in our task file oh, we do have debug HTTP server, right? Not a bad idea. Here we actually want CLI args like this, presumably to be passed. Ah, no, we cannot in fact. GDB is a piece of shit, so that is not going to work. Set args 4200. Actually, it's probably not GDB's fault, to be clear. It's probably me. Just so we're clear on this, I don't want the GDB or GNU mafia to... I'm very sorry for what I said. It won't happen again. Anyway. My watch is telling me that I have to walk a little bit. Actually, it's telling me that I have to stand a little bit. And that's a lot of threads. Actually, okay, no. Yeah, our thread pool is creating 100 threads actually. That's not a problem at all. Let's see here. We want to debug something. Here I'm actually curious now. Yeah, let's debug handle client because now I'm curious what actually happens. Break HTTP server. Debug handle client. Is GDB just sort of... Oh, it's not taking... Hang on. It's really not taking input at all. That's curious. I may have left a GDB init file somewhere. No. I have not, in fact, left a GDB init file. That's what I tend to do, and then I'm confused when it doesn't behave as I think it should. This is not the case right now, of course. run. Sure. This is just straight up not taking any input at all. But if I control C, okay, let's try here now. HTTP server, handle client. We could set this in a GTP init file, which we will do if this turns out to be a problem. Okay, now we have a bunch of threads. Now we are executing. By the way, if you're having problems with GTP, because you can see here, I'm running the focus command, right? If you're having problems pressing up and down and you're like, hey, I really want to see my history, you know, you can just do focus CMD like this. And now you can actually see that the arrows actually, you know, give us what we last executed and so on. I just think that's a useful thing to know. So client socket here. Receive buffer. And here you can do Control L, by the way, if you want to redraw. If you have a bunch of logging and so on, that is very useful. So, you know, like now, for example, we have a bunch of output here, of course, then that sort of needs to be cleared, right? I can see now that we have gotten a response. And now we're closing the socket. And now I'm basically seeing the web page. Hang on. Oh, now we're doing favicon. Let's see. Yes, favicon icon. Yeah. That's all fine. We're sending a 404. Then we are continuing. And here we're going to be sitting, blocking, in fact. I feel like there's a better way here, no? We should be doing this in simply one connection, in fact. And of course, because I'm closing it now, we're kind of seeing this kind of behavior. Let's see if we can just sort of send a double new line here or something after the first one. So we don't have this close here. In fact, we just loop around. And here we send the welcome message. But then we also send this. We don't necessarily want to debug here just yet. Let's see here. Though I'm not sure. Yeah, connection keep alive is obviously what our browser is saying, so we do want that. ask the RFC here actually. Sure. Let's see here. Oh, hang on. Hang on. This may actually be right. Content length. I mean, this is of course like a completely hard-coded value here, but I do want to see that it makes sense. I'm not sure about this one here. Maybe it doesn't matter. Now we got a seg fault here. Let's debug that. So I can see that I have the page at this point. Presumably this is now the fav icon. Well, this is hard to read, isn't it? Oh, now, hang on. No, now we are getting the empty path. We're sending that again. Now this is where we send TCP. This socket is not alive anymore, presumably. And we are in fact sending on it. So I'm going to remove this, I guess. What happens if we disable this entirely? That could be interesting, because we of course have our initial You can see here that the fav icon never actually gets its result though. And that might be... No, here we don't need a body, certainly. Let's try this for now. Okay, now we're getting 2 solid responses. 1202, 1404. Connection is still basically, I guess, open. But this is what our browser asked for, right? So we should be fine here. Actually, I wish there was a way to see your connection status, like in Firefox. Because clearly it doesn't have the connection open for that long. Maybe we should log this actually in our code here. Right? If we receive 0 bytes or the receive error is, let's see here. If receive error is equal to net TCP receive error dot hang on, connection closed. This one I honestly have not seen very much. We could do an OR here, or n is equal to 0, connection closed. Right, and log debugf here will obviously take the logger from up here. Let's try this, right? I just want to see sort of when is our client actually exiting. So now I'm going to do a control F5. We get both files. And I'm expecting the client at some point to just say, oh, obviously, like I can not keep this connection alive. I'm reasonably certain that Firefox doesn't just sit there. Does anyone know this? I'll be very curious in the comments if someone could just say, no, Firefox keeps a connection open for, you know, this amount of time, for example, right? Because we're just sitting here, presumably actually just receiving right now, right? And I'm curious because Firefox, of course, can decide to close this connection. And I'm curious now, like, what is the actual behavior? And what is the behavior of Chrome in this situation? That's also an interesting thing, right? What if we check this, right? 127.0.0.1 4200. That's a seg fault right there. Let's see here. Connection closed. I suppose that's the first one. What happened with the second one? Oh. All requests from Chrome fail. Now that's curious. That's maybe something we want to look into. Probably we want to GDB that, probably because you can see we're getting basically no information here. I mean, we could take a look at the actual log first, right? Path, you know, empty as we would expect. We have the protocol here, headers, cache control, max age 0. We don't do any cache at all right now, so that, you know, doesn't come into it really. The user agent is useful as usual. Mozilla, Apple WebKit, and so on. That's interesting. Accept text HTML, and so on and so forth. User sec, CHUA, Google Chrome, Chromium, not a brand. What even is this? Connection, keep alive, sure. A lot of this seems fairly normal, but clearly we are ending up somewhere a little bit strange, right? So I'm gonna connect again. Oh, we're gonna run, of course. It's always good to run your program if you wanted to actually do anything. Oh, hang on, set. We need to set args, of course. There you go. I started the thread here. Our output here is what we would expect. Oh. So, what? What? The program no longer exists. That's curious. Okay. Hit breakpoint. What? The program is not being run. What is going on? Okay. Let's do some old-fashioned logging and see actually what is even happening here. I'm not sure what is going on here. This is just me using Chrome. 4200 was the port that I was using. Yeah, everything seems fine there. What could this be? Let's raise this to something ridiculous. You never kind of know, honestly, with some of these things. Okay. We can see here that header's too long. So hang on. My Chrome is trying to send headers that are longer than 64K. What the fuck? Are you kidding me? What? So obviously that was the case. But this makes very little sense to me. Okay, let's try to find where that would happen. Header's too long. I've hard coded, I think, you know, hey, I think this might, you know, this should be fine for the time being. Max headers length here, we can see that that's 32 times 1024. What we can actually do here is just say mem kilobyte. There's no reason to have 1024 there. And what we're gonna do here is we're gonna say 64 and see if that changes the stuff. I am very curious to see what Chrome is sending. And so here, what are all of these requests? So we have get, we're sending a response to that. Then we have a get for slash again. Why exactly? And then we have a get for slash again. What the fuck? Why? Why are we requesting slash 3 times? This is genuinely mystifying to me. Let's see if we can. Oh, hang on, right. It's doing all of this at the same time, right? Of course. Because Chrome is like, hey, I should spawn like 50 million threads and do all of this at once. And our program is basically saying, hey, I am failing somewhere. Let's see. If we don't have any breakpoints, we should be getting our seg fault. So here, one of our send calls is failing here. We're attempting to send this welcome message, and presumably the connection is not open anymore, or something like this. Sure. So one of our threads is basically sending to a connection that I guess is already done or something like this. I mean, that would kind of make sense here. There you go. So for those who might not have seen this, so you can label your force, right? And of course here, what I'm saying in here is basically I want to break out of the outer loop, right? If we only did break here, we would just break out into, you know, this one. We would break out of this one, right? And so on, which we might still want to do, right? Because we may have received some stuff here, right? Still. And this stuff here, we probably want to modify somewhat, to be honest. I think a little bit of this logic we probably want to deal with, to be honest. Maybe rewrite this. So yeah. Anyway, this now seems to be working, so that's fine for now anyway. Okay, let's make sure Firefox is fine with this. Yeah. And the code seems to be just doing what it needs to be doing, so yeah. Of course, the code that I added here, by the way, if you're wondering, hey, because we did not have this break before, right? We just said connection closed, and then we tried to kind of move on, and that is not what we wanted to be doing necessarily. Now we're breaking out of this entire receive, which again, we might not want to do because we may have received something before we actually got data here, or before we received nothing, basically. Anyway, let's leave that as it is for now. And here, what we could do, we're still gonna log our request, I suppose. I don't want to log what we send necessarily anymore. Not super concerned about that. Here we could say else if request.path is equal to /ws, like this. And here, I actually want to say key is request.headers, and then exactly like this, right? So in the headers here, we should have this key here. And here we can say has key, like this. And if not has key, the sec WebSocket key is actually a required thing. So what we could do here is basically disconnect whoever is trying to connect or whatever. We could do all kinds of stuff here, right? In order to just basically say, you know, you're doing something wrong. We could send a response here that says, you know, you're wrong. So we could build up this response here, 400 bad request, etc. Like this, right? And this would be the actual error handling here, right? Let's say, right? We also want a few other headers, to be clear. We're not necessarily concerned. Well, no. Let's take a look at this. Where have I put this? I put it somewhere. Hang on, let me find my notes. I have way too many windows nowadays. Actually, I'm wondering, like, how did I end up with this many windows at this point? Let's leave that there. Ah, there you go. Jesus Christ. So here we have the actual notes here on what we require. The required headers here are actually sec WebSocket version and so on, also host, upgrade, which has to include WebSocket. Simpler at this point to just say it has to be WebSocket, because it's basically what people put there. Upgrade, I don't know why you would put anything else. I suppose you could try to communicate something to the web server, but there really is no point. Just to be clear, what I'm talking about here is the client handshake. This is how we initiate a WebSocket connection, basically. We have actually say basically, I want to upgrade this to a WebSocket, basically. So it looks something like this. And connection has to include upgrade, right? And again, it makes more sense for us to just say it has to be the word upgrade. you could argue, should it be, you know, does it need to exist and so on? Well, yeah, let's just say that it needs to exist, right? The value that we're mostly concerned with here is sec WebSocket key. This is the one we actually want to, you know, pull out of this, right? So let's do that. We have this key and hash key here. Then we can say connection, hash connection, header. Let's just say this, like this. And here, if we, yeah, sure, this seems mostly reasonable. Upgrade header, same thing there, like this. Here we want WebSocket version header, like this, right? This one also. By the way, I should say, so that no one gets confused about kind of what we're actually doing here. Let me just sort of bring up the chat. We will package this up basically in some kind of way of saying, hey, on this path, I want to listen for WebSocket stuff, right? We're writing this code so that we don't over abstract stuff into some nonsense before we have an actual use case. Same thing with the actual client. That's what we actually did there as well, because it really makes no sense to be super concerned with abstracting stuff before you have something that actually makes sense, something that actually does a thing, right? This is something that people usually honestly fail at, because they haven't really thought through the whole process of actually making stuff, to be honest, that much. So connection we have our host we also need. And here we're doing zero validation on this at the moment. Origin is really only needed if you come from a browser. So I'm gonna say kind of, you know, fuck it and not really care about this. Extensions you could do. We're not gonna do any extensions, WebSocket extensions. This is the sec WebSocket extensions header and so on. Protocol you can also do. Most of protocols are really only for both sides to agree on, meaning if a client connects and it says, I support this cool company protocol, the other side can say, oh, that's cool, I have that one. But there's no directory of protocols for WebSockets that you can follow, for example, right? So it's completely pointless to support this in a general WebSocket kind of way and so on. And here we want to, of course, send the correct things. The accept value here is interesting because we actually want to calculate this. And I have these in my notes as well. Let's see here. Here I actually have this in my notes. When this is sent back, first of all, we have this shape, right? We can see that this is basically what we have started working on. And we will read the value in sec WebSocket key, right? And then we concatenate this with this specific GUID, right? We concatenate those values together. We then SHA-1 hash it, that value, basically. And then we base64 encode that value and send it back. And we get something like this, right? So that's basically what we want to do here. Accept value. And I suppose this could be something like this. You'll note that most of these are bogus modules. They don't actually exist like this. So what we're going to do here is write bogus here. So I have something to return to. And then we're going to say encoding base 64, right? We're also going to say import core hash like this. Now we can jump down to the bogus here again and basically say, let's see, concatenated value is bytes concat. This one should probably be fine. Here possibly we could do this, bytes concatenate. The key here is a string, so that's not actually quite what we want necessarily. We want actually strings concatenate. And here I'm going to import strings like this. And this of course is no longer this. It is actually a slice of strings. So our key is a string, and here of course we actually want just the string value here. This is our concatenated value. Then we want to SHA-hash this. SHA-1 hash is equal to hash dot, and here I do think it's SHA-1. We may have to slash this. Let's check this out a little bit. No, let's see if package.odinlang can give us something. SHA-1, 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 SHA-1. So this is in the hash crypto. Of course, crypto SHA-1. Oh, we have to actually access this from legacy. Okay. Interesting, to be honest. Not 100% sure I would want that, but okay. Hash string, concatenated value. Importantly, concatenate here takes an allocator. We have already set this for our request, so we'll just be using that. And here hash string blah blah blah. We get a hash out of this, right? And this is digest size array, right? So if we go to this, we can see that it's 20 bytes, and that should be what we have. Then we base 64 encode this, and we'll see here what this requires. Again, this takes an allocator, returns a string, and we should be fine if we slice this, because if we don't, we should see that there's an error here actually. Let's write this as well. Here so here you can see that this expects, of course, a slice of bytes, and we have an array. Now when we slice into it like this, it all type checks instead. Let's take a little bit of a tiny break. I have to walk a little bit, to be honest. Stretch the old legs. I will be right back. Let's see here. Back soon. Ciao for now. All right. A little bit of doom. To be honest, one of the reasons that I'm playing the Doom stuff is because it is definitely not copyright struck on YouTube, which is good news. I can also say the same for Dead Mouse. In fact, that is copyright. Basically, they recognize it in the copyright system, but Dead Mouse allows it to be played, which makes it, well, that's good, basically. It makes it so that you can actually use it, and it's fine. So, now this is interesting, right? Because we are now sending basically this, okay, we're switching now to WebSockets, right? So what we actually want to do here is a loop that just does WebSocket things, right? That's basically what we want to jump into here, right? Because at this point, all of this stuff, right, is essentially just us saying, okay, we're gonna transfer this into basically WebSocket stuff, right? So what we should expect here is basically, okay, the client now will know that we have transitioned, right? So effectively, kind of what I'm thinking here is we send this content and then we just go. We do jump into this loop, probably. We can do byte sent here for sure, like this. Sure, buffer to bytes. This is not actually what we want. We want to actually say switching protocols message, like this, right? This is buffer to bytes, and here what we actually want is this, except you can see here that this loop is basically saying while we haven't sent enough, send more. And this is not going to work with this over here, because we actually want here to say bytes sent forwards, right? Like this. Because then, let's say we send 5 bytes. If we had this code here, we would just be sending the same message over and over. Send 5 bytes and then send from the beginning again, and that doesn't make any sense. So we actually want bytes sent forwards, right? Because we send 5 bytes and then we start from 5 and we send forward, for example, right? And here, here it thinks we should have some kind of WebSocket state, which is fair enough, right? But it's effectively here, what we actually want is a for loop that just sort of sits and communicates WebSocket stuff, right? Effectively. So now we might wonder here, if we should just jump over to a completely separate thread here. For now, we don't really need to, I guess. So this is the general structure that we have, right? Let's see here. Let's start the server, and I'm going to use a tool here. Let's start this here. And I'm going to use yet another terminal here to use WebSocket with our local server, like this, /ws, and see if that can coordinate this, right? So now we're connecting a client here, and I'm going to try to, let's see if I can find this WebSocket. It has some good parameters here. It's -v -vvv you can do, which will give you a lot of diagnostic information. Let's do double V like this and see what happens. So server, that's not necessarily what I wanted, but let's see. We can see a request coming in here. Let's just add some logging here to see that we're reaching the right paths. I'm gonna add some really obnoxious stuff here. We're gonna also do a time sleep here because otherwise it's gonna be probably a bit too much. Sleep takes a duration, so what we can do here, I guess, is time second like this. Yeah, let's try that. Let's start the server. That's not the server. Let's connect our WebSocket client here. This is connected now. Underlying connection established, and so on. And here we can see we're now waiting for data. Right, so our WebSocket client that we didn't write can connect, and it sits there and does stuff. Right, that's good. That means that yes, we do have something that basically goes through the motions of just establishing this connection, right? And now we basically would have to have here parse WebSocket fragment, right, which is in our HTTP client right now. We're probably going to try to move this to a WebSocket package, right? And move, because both sides need to do this stuff, right? We of course have it in our client here because that's what we were working on, right? So probably we are going to move that into a WebSocket package here, or HTTP. Kind of depends. Honestly, over organizing stuff like this is a dangerous thing because it doesn't actually matter that much, right? Put stuff where it vaguely makes sense. Don't over organize. Don't make these huge taxonomies in your file systems. It doesn't make any difference in the end, to be honest. It's the kind of thing that people focus on when they have nothing of value to do. So be aware of that and stop yourself when you do this. And I'm saying this is, you know, coming from someone who has certainly spent a fair amount of time doing pointless bullshit things, because, you know, organizing things and so on feels good, but it's a massive waste of time for the most part, and so on. So parse WebSocket fragment. This of course depends on a few things. So what we're gonna do is we're gonna just rip out this code entirely, right? The entire thing, and put it in some kind of a WebSocket file or something. We could put it in HTTP here. And that's actually what we're gonna do. We're gonna say WebSocket Odin here. And this is package HTTP, bam. Now, this is of course gonna be lacking a bunch of things. WebSocket fragment, for example. And the key here is that we can now go back and say WebSocket fragment, you know, oh, that's the thing I need, and so on and so forth, right? Basically everything that has to do with WebSocket underscore is probably going to be stuff that we pull out, right? So we could just take a bunch of these things now and just say, hey, I'm going to remove this. So WebSocket fragment, fragment data, continuation data, text data, binary data, close data, ping data, pong data, parse error, of course, invalid opcode certainly is something that belongs to that, right? Bam, we're gonna pull those out, switch back here, save, log, import core log, it's fine. Oh, that seems to be it, to be honest. That was painless. Now we save this, and of course this doesn't have access to these things. Serialized WebSocket fragment seems exactly like the kind of thing that we would want in this other file. So we're going to take that as well. And yeah, I think that's probably going to be relevant to us here. Serialized WebSocket fragment. Hang on. Yeah, okay. This entire function, I suppose. Fragment serialization buffer not used. It is used, in fact, but here we are calling serialized WebSocket fragment here with this, right? And presumably this is just hang on, let's see here. Parse WebSocket fragment is http dot parse WebSocket fragment now. Now we have more errors. Here we can do HTTP ping data. Undeclared name crypto. Well, I removed that import because it said it wasn't used. I suppose I was wrong. It was wrong, in fact. This is an HTTP WebSocket fragment. Same with pong data, of course. And here's HTTP, this, and so on. What we maybe can do here is dot only. No, we cannot. It comes from a different package. So HTTP dot is what we want for all of these. Like this. And that seems to be compiling now. That does not necessarily mean it works. Just so we're all very clear on that. We can start the server now and see if it does the same thing. This is a fairly simple refactor, so I don't see why it shouldn't. And now this all seems to be running like it did before. So now we've established this connection again. We've moved the code a little bit so that the server can basically use this code to parse stuff. We have a receive buffer here, correct? I feel like bytes received here is definitely going to be shadowed. So what we could do here is receive data, and we could say um, 4 bytes received less than 2. That does not seem, no, that seems while it's less than 0, I suppose we could do, but I don't know that we actually have to, if I'm being completely honest. We could just have a 4 here and we break. We don't have break receive here at all, we have just break. Connection closed. If we just get an abrupt disconnection, there's really not that much we want to be doing. WebSocket receive. Let's call this like this, and here we could actually break WebSocket receive. It's not really a big deal. Here we're breaking out of this, and here I probably want to break out of all of it. Here we received some content, and so we're gonna log that for the time being. This received less than 2 bytes. I don't know what Copilot means by that. Maybe we'll have some insight into what that means later. Of course, you do require some amount of data in order to have a valid fragment. But this is of course handled by our fragment code, like the parsing code for that. So I'm not super, concerned with that. Let's say fragment here and remaining data. Fragment parsing error. is equal to HTTP parse WebSocket fragment like this. And here we take just a slice of bytes. So that's our received bytes here, like this. And here we will say, let's confirm here, we have a frame. It's not a frame actually, let's change that. Fragment, we have a fragment. We have some remaining data. And here we want fragment.final. We want fragment. Of course, we can just say frame fragment GC like this. We step through and say yep. Indeed, like this. We go back to here and we say now, this returns a fragment. Now everything is good in the world and so on. Here we want, if we had some issue parsing this fragment, we want to just say, we failed to parse this. Otherwise, let's log it. I think that's a good idea. Sure, if the opcode is close, we might want to just, close. I do want to log that though. Closing connection because other side close sent close fragment. Let's be super specific. This is not an opcode as such. This is close data. This is not, opcode doesn't exist like this. It's actually, let's just do switch t in fragment data like this. We might change this, just to be clear. I do think that the opcode could just be an enum and so on, but here we want close data like this. And we're gonna put the same code in there, like this. And let's do effectively this, I don't mind this at all. Binary data, receive binary data, yep. Ping data, pong data. That's it. Close. What we could do here is order them in the order that they would be otherwise. So down below this, we actually have control fragments, and above we have non-control fragments. So close comes first, ping comes second. Close is actually 0x 08, I think. Then we have 9, and then we have a, something like this. Fragment.data pong, that doesn't make any sense over here. We actually have t here, t payload like this, and t payload. We're gonna put quotes around these because I usually get confused about that, and so on. And here we're gonna put quotes around this again. The reason is sometimes you'll have new lines and stuff, and it's not clear what you're actually doing. Right, continuation data, this actually comes, this is the first one, and we want to do basically the same thing for that one, so let's just do that. Core time, sure. We could try running this now and see what happens. Now we're running the server. Let's connect our client. Oppa. And now we should be seeing basically nothing. Like, we've accepted a request, sure. If I say something here, press enter, we can see that we received something here. However, we're not necessarily seeing here that anything is getting parsed or otherwise, right? And that's interesting. So we're logging this on line 243. So what does that mean? 243. It means we are logging this in WebSocket receive. So clearly we've entered the whole WebSocket receive state, right? But we're never exiting here. And that would make sense, right? That would actually make sense here. I'm going to actually say break here. This seems a little bit pointless. We're going to rework this maybe at some point. Yeah, let's do that. So we can see that we're actually receiving data. That's a good sign, obviously. We're in the WebSocket receive loop at that point. So we're definitely handling the steps before that, right? Let's make sure we're still on the right track. We are in fact on the right track, like this. So here we can see now that we've received some data. It looks completely bogus to us, of course. We have an initial length 27, opcode is 01. That's text data, indeed. We have text data here. Our fragment is a WebSocket fragment with text data inside of it. Mask is true, final is, no, mask is false, final is true. We have no mask key. We receive text data, in fact, on the right track, new line. So that seems good. We're obviously now processing these, and presumably there's no way from this client to set it to binary mode. I have no idea really how you would do this. I'm going to try exiting that and just say WebSocket help, and let's see here, and say binary. Let's search for that. Send message to WebSocket as binary messages. Let's try that, right? So let's do a -b here, like this. And now we are sending binary messages, right? Let's see what that turns into. Received binary data. Now we are sending binary messages, right? So, okay, we're up and running. We have some kind of idea about what's happening here now, right? The time is 19:57. I'm not entirely sure we're gonna do much more. You know, we've set this up now. We have a server that actually goes into a WebSocket loop. I think this might be a good kind of place to step back and look at, you know, okay, what have we done and what would be the next steps in order to generalize this somewhat, right? Because now we have something that actually does sort of the correct thing, right? It negotiates via the handshake what it needs to be doing. I'm a little bit curious actually, because you can see here, and if you followed the previous streams on this, you'll note that clients should always mask their messages when they come in. And it seems honestly like our WebSocket client doesn't do that. I'm very curious why that would be the case, because I think the RFC basically says pretty clearly we should be doing that. But this is actually a great moment to talk about something that I was wrong about on the previous stream. So the keywords must not, required, shall not, should not, and so on in this document are to be interpreted as described in this RFC. If we go to that RFC, we can see that this is exactly the kind of bullshit that I talked about on a previous stream, where you would have these RFCs that were too relaxed in what they said, right? And this is a great thing to talk about, because should, when the RFC on WebSocket says should, what that actually means that it is strongly recommended. This word, or the adjective recommended, means that there may exist valid reasons in particular circumstances to ignore a particular item, but the full implications must be understood and carefully weighed before choosing a different course. And of course, what I was complaining about in a previous stream was that the Golang WebSocket library was effectively not enforcing something that said should. And now I will invite you to think about, did they do that because they have somehow weighed these alternatives? No, of course not. They basically decided to ignore effectively the spec because this is bullshit. When you allow people to simply not do a thing, they won't do it. And of course, what the Golang libraries were basically doing was that they did not enforce that you send a ping or a Pong response to with the same content that they pinged with, right? And if we go to the RFC, right, so we go here to Pong. We go to Pong, right? If an endpoint receives a ping frame, hang on. Let's see here if I can find this. Right, a Pong frame sent in response to a ping frame must have identical application data as found in the message body of the ping frame being replied to. Actually, it says must. This is straight up must. And this is never enforced by Golang, the Golang library, at all. You can send the wrong Pong data and it will just happily kind of move along, to be honest. And this I find a little bit dumb, if I'm being honest, because this is exactly the kind of thing where just implement it like it says, right? So I was wrong about being wrong, to be honest, because it clearly says must have identical application data as found in the message body of ping frame being replied to. And if you do the wrong thing, it just says nothing. It just, Golang doesn't say anything. Hey, you responded with some BS, right? This makes it harder to implement, to be honest. But yeah, anyway, let's move on from there, I guess. What are our next steps? At this point, we have basically set up this specific, let's see here. We have an if, right, on our path, right? So, two things. We have these if request path equals something, right? Let's basically turn this into a table with handlers, right? Each handler receives some kind of request structure. We parse a request, we pass that to a handler that you specify, right? So the idea would be effectively, let's say, for example, that we have server.register handler, right? And we have this, sure, this sounds great actually, WebSocket handler like this, or handle WebSocket like this, right? When you do this, you basically pass this procedure here, function pointer, effectively. When the server parses some kind of request, what it's going to do is basically call handle WebSocket with that request structure. It will basically spawn a thread to call handle WebSocket here. And so what we'll do is basically fav, fav icon ICO like this, right? Because we of course have that here, right? This one we will pass a proc that does this stuff, right? So this here, register handler here, will basically be managing effectively a table of paths and handlers, right? So this handler table, right, would be effectively a map of string to proc of request, which is an HTTP request indeed. This is looking beautiful, right? And this returns maybe just void, right? Like this. So the handler here is responsible for doing stuff. We are responsible for calling that handler, right? This is obviously what a general web server would be effectively, right? So I think that this would be a great next step to kind of generalize some of this stuff, right? Then basically all of this code is going to disappear, right? This stuff here is going to disappear. We're going to establish effectively a general WebSocket handler function, right? And you can see now kind of past what I'm talking about. You can see how maybe we will say like, oh, handle fragment, right? You pass to this WebSocket handler some kind of handle fragment or something, right? Maybe. It kind of depends, right? We will start out basically having, oh, you specify just a proc here and that proc does a thing, right? in our particular example, we will have this handle WebSocket function. The first thing it will do is basically say, oh, I need to negotiate the WebSocket, and then I'm going into a loop. Effectively, it's going to do exactly what we're doing here, right? And so that's how we're going to approach this entire web server thing, right? This here will be basically what we have. Probably at the beginning, we will have server register handler like this. It won't actually be dot at all. It will be server underscore register underscore handler, right? That will be a function that basically adds to a table and blah, blah, blah. That table is then looked at when we receive a request and blah, blah, blah. So we know how to route this and so on and so forth, right? Basically. This also means that we have to kind of examine a little bit our handle client flow, perhaps. I'm not entirely sure. We might just straight up call procedure. Yeah, okay. We already have a thread at this point, right, for our request. So we might actually just say, no, don't start any new threads. Just jump into the handler from this code straight up, right? In that case, what we actually would have here, server register handler, of course, would happen somewhere else. Like, assume that this is implied, right? And then we would say, basically say handler has handler like this, right? Go into the handler table, right? And pass the request path to it, right? If has handler, right? That's a 404, right? Send 404 here. We can't find this path, right? Otherwise, we will basically call handler with the request that we have, basically. And so that's going to be probably the next steps that we're going to be doing. This will allow us, of course, to basically start working on a bunch of different handlers for different cases and so on, right? And you can imagine here that, yeah, we will approach something that would looks effectively like, you know, quote unquote modern web development to some degree. We could certainly actually even start doing things like HTMX, right? For those who might not know what that means, HTMX, here's the acronym that I'm talking about. Usually written just HTMX like this, and so on. It's really just based on normal HTML, except there's a library client side that handles a lot of stuff in a very, very simple way. The only thing the library does is figure out how to call new requests and handle the data that comes in and so on. It's all based on normal HTML, so we could definitely implement something like that basically supports that way of doing things, because it is all very request response based and so on. So we could definitely start looking at that. We could also actually handle headers that have to do with HTMX as well in our handlers functions, because those functions are going to be completely separate from the logic that figures out what handler to call and so on. So we're going to be basically adding this general structure, right? And I think we're very well set up at this point to actually start breaking out a lot of this code to do those things, to be honest. We are going to have to share some level of state here, just to be clear, right? So if you look here at our main, right? This is our main function. We go down here, we start our thread pool, of course, here, right? And then we start receiving clients, right? And here you can see that pool add task, right? At this point, this handler table already needs to exist, right? So you can imagine here, this code down here, right, needs to exist basically here, right? This code needs to exist up here. We register our handlers and blah, blah, blah. We can also generate these handlers, to be clear. Like we could read them from a file if we wanted to and so on. But we have this handler table here, right? And of course, each thread needs some level of access to this table, right? So what we will do there, first of all, the implicit assumption here is that clients only really read the table, right? And the server only modifies it while it's starting up, right? That's the assumption we're going to make right now, because that kind of makes things easier. Nothing is touching this memory while stuff is running, right? And so this lookup that we have down here should be completely safe, right? The handler table is frozen, right? While clients are running, nothing is actually modifying this, right? So this server handler table here, though, that Copilot came up with, right? This, of course, needs to be accessible somehow, right? So it's either going to be a global, or we will pass in a pointer to it in our thread state, right? Each thread state will have a pointer to the handler table, and that pointer, of course, remains static, right? That memory will always just exist, and we will be fine, right? Importantly, none of the threads actually own this handler table, right? They will not deal with modifying that table in any way, right? And they just have a pointer to it, right? Anyway, I hope that makes sense as a way of doing things, of course. Why is this? Yeah, undeclared name, of course. Assignment count mismatch, of course. Like, yeah, this makes no sense. We don't have a handler table yet. But this is basically what we're going to be doing next stream, which I guess will be actually tomorrow, because I kind of feel like I want to just do this and so on. I'm wondering a little bit, maybe people will, you know, I'll be curious if anyone is watching at this point, this late in the stream. But if anyone is interested in having 2 streams per day, one for European time zones and one for quote unquote other time zones, that could be an interesting thing to do. It depends a little bit if people want this, right? Certain days I can certainly do this, but I'm curious if there's any kind of demand for it. Because of course I'm doing this in the evenings, my time. The idea would be to do this during the day otherwise. But yeah, I'm curious if that is something that people want. Anyway, here is where we're gonna leave this. Tomorrow, we're gonna be working on generalizing the server a little bit, registering handlers, having those handlers be called by our web server infrastructure and so on. And the handlers themselves can then say, hey, this request is good, bad, whatever. The only thing we're doing in the main code is basically routing to handlers. So that's it for today. Very happy that we had people in the chat and so on. And thank you for being there. Thank you for watching this if you are after the fact and so on. And yeah, ciao and have a nice day.